Welcome to the Story Guide. Sir Isaac Newton, a name synonymous with scientific revolution, was an English physicist and mathematician whose contributions reshaped our understanding of the universe. Born in 1643, Newton's life was a blend of extraordinary intellectual prowess, groundbreaking discoveries, and a complex personality marked by both brilliance and eccentricity. His work in mechanics, optics, and calculus laid the foundation for modern physics and mathematics, leaving an indelible mark on the scientific landscape. Early life and education. Isaac Newton was born on January 4, 1643, in Woolsthorpe, a small hamlet in Lincolnshire, England. His father, a farmer, died 3 months before his birth, leaving Newton to be raised by his mother, Hannah Askew. When Newton was 3, his mother remarried, leaving him in the care of his maternal grandmother. This separation from his mother during his formative years is believed by some historians to have had a profound impact on his personality, contributing to his later insecurities and volatile temper. Despite a somewhat tumultuous childhood, Newton showed an early aptitude for mechanics and invention. He enjoyed building mechanical devices, including sundials and windmills. His interest in mathematics was sparked by a book on astrology he purchased at a fair, which he found difficult to understand without a solid grasp of mathematical principles. This spurred him to delve into the works of mathematicians like Euclid and Descartes, quickly mastering the mathematical tools of his time. In 1661, Newton entered Trinity College, Cambridge, where he initially intended to study law. However, his fascination with mathematics and natural philosophy soon took over. He immersed himself in the works of leading scientists of the time, including Galileo and Kepler, and began to develop his own ideas about motion and gravity. The annus mirabilis and the birth of modern science. Between 1665 and 1667, the bubonic plague swept through England, forcing Cambridge University to close. Newton retreated to his family home in Woolsthorpe, a period that would become his annus mirabilis year of wonders. During this time, he made remarkable advances in mathematics, optics, and mechanics. It was during this period that Newton is said to have witnessed an apple falling from a tree, which led him to ponder the nature of gravity. While the apple story may be apocryphal, it captures the essence of Newton's insight, that the same force that caused the apple to fall to the ground also kept the moon in orbit around the Earth. This led him to formulate his law of universal gravitation, which states that every object in the universe attracts every other object with a force proportional to the product of their masses and inversely proportional to the square of the distance between them. In addition to his work on gravity, Newton also made significant strides in optics during his time in Woolsthorpe. He conducted experiments with prisms, demonstrating that white light is composed of a spectrum of colors. This discovery challenged the prevailing Aristotelian view that white light was a pure and indivisible entity. Furthermore, Newton developed the foundations of calculus, a new branch of mathematics that deals with rates of change and areas under curves. Although he did not publish his work on calculus until much later, his insights laid the groundwork for future developments in mathematics and physics. Principia Mathematica, a monumental achievement. In 1687, Newton published his magnum opus, Philosophiae Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy, commonly known as the Principia. This work is considered one of the most important scientific books ever written. In it, Newton laid out his laws of motion and universal gravitation, providing a comprehensive and mathematically rigorous description of the physical world. The Principia revolutionized our understanding of the universe. Newton's laws of motion explained how objects move and interact, while his law of universal gravitation provided a unifying framework for understanding celestial and terrestrial phenomena. He was able to explain the tides, the orbits of planets, and the motion of comets with a single set of laws. The Principia not only established Newton as a towering figure in science but also marked a turning point in the scientific revolution. It demonstrated the power of mathematics and observation in understanding the natural world, paving the way for the development of modern physics. Later life and legacy. After the publication of the Principia, Newton's fame and influence grew. He became a professor at Cambridge University and later served as warden and master of the mint. In this role, he oversaw the recoinage of England and played a significant role in stabilizing the British currency. Despite his administrative duties, Newton continued to pursue his scientific interests, particularly in optics and mathematics. He published his second major work, Optics, in 1704, which detailed his experiments with light and color. Newton's later life was also marked by controversy. He engaged in a bitter priority dispute with Gottfried Wilhelm Leibniz over the invention of calculus. While both Newton and Leibniz independently developed calculus, their followers engaged in a heated debate over who deserved the credit. Newton's personality was complex and at times difficult. He was known for his intense focus, his reluctance to publish his work, and his fierce defense of his ideas. He was also deeply religious and spent a considerable amount of time studying theology and biblical prophecy. Isaac Newton died on March 31, 1727, and was buried in Westminster Abbey. His legacy is immense. He is widely regarded as one of the greatest scientists of all time, whose work laid the foundation for modern physics and mathematics. His laws of motion and universal gravitation remain cornerstones of classical mechanics, while his development of calculus provided a powerful tool for solving a wide range of scientific problems. Key contributions of Isaac Newton. Laws of motion. Newton's 3 laws of motion describe how objects move and interact. These laws are fundamental to classical mechanics and are used to explain everything from the motion of planets to the behavior of everyday objects. Universal gravitation. Newton's law of universal gravitation states that every object in the universe attracts every other object with a force proportional to the product of their masses and inversely proportional to the square of the distance between them. This law explained the motion of celestial bodies and unified our understanding of gravity. Calculus. Newton developed the foundations of calculus, a new branch of mathematics that deals with rates of change and areas under curves. Calculus is an essential tool for solving problems in physics, engineering, and other fields. Optics. Newton made significant contributions to the field of optics. He demonstrated that white light is composed of a spectrum of colors and developed a theory of color. He also invented the reflecting telescope, which greatly improved astronomical observations. Conclusion. Isaac Newton was a towering figure in the history of science, whose contributions revolutionized our understanding of the universe. His work in mechanics, optics, and calculus laid the foundation for modern physics and mathematics, and his influence continues to be felt today. While his personality was complex and his later life was marked by controversy, his intellectual achievements remain unparalleled. Newton's legacy is a testament to the power of human curiosity, ingenuity, and the pursuit of knowledge.